So today we are going to start with a new topic. Write down the topic name as phase angle and phasor. And I want your complete attention for these topics. Phase angle and phasors. Okay. So first case, we will consider sinusoidal AC current with a phase angle of 0. So here is my sinusoidal AC current which I have drawn. It can be written as small I. What is the expression? How do you write the expression? I is equal to Im sine omega t or sine theta, where theta is omega t, right? So whenever a AC signal or AC current starts with a reference 0, when it starts from 0, or we can call it reference or origin position, we say that it's in phase. The phase angle is 0 degrees. So this is my phasor diagram where x-axis and y-axis. I have drawn the phase, I in the direction of x-axis, indicating that the phase is 0. So please draw these two waveforms. So I have drawn the sinusoidal AC current with a phase 0 phase angle. Okay. Now you will understand when there is a phase difference in the next case. Is this clear to you? Draw the phasor also. Where what is phi? Phi is the phase angle. Okay. Completed. Now, this year, current I attains a 0 value exact at the reference position, where reference position is 0. Your phi is 0, that means the phase angle of the current is 0. Okay, now you must be writing this as a standard form, but this standard form is incomplete. The actual standard form is this. This is the new standard form, please write it. It is Im sine omega t plus or minus phi, where phi is the phase angle. So far, I have not talked about it, but right now we are introducing this. So for our case, it is Im sine omega t plus or minus 0 degree. So that is same as Im sine omega t. Did you get it? Yeah. So whenever there is a phase difference in phi ki jagah, that angle will come. All right. Scroll upward. Where? You have come late. So write fast, please. Understood? I is equal to Im sine omega t plus or minus phi. Here phi is 0, so I is sine omega t only. Can I proceed now down? Okay. AC current is generally referred by its RMS value. So normally I is RMS divided by root 2. Okay. Can we go to the next case? Case number 2, where a sinusoidal AC voltage have a negative phase angle. So let's check it out. When it have look at this waveform. What can you gauge from this waveform? No, this sinusoidal waveform is not starting from 0. It's starting with a delay. And what is that delay? What is pi by 4 in degrees? 45. Okay. And why we call it negative phase angle? Because it's a delay. If it was early, if the waveform would have started from here, let's say, then would have been a positive phase angle. Since it's a delay in the start, that's why this is my reference position. This is my phase. 0 to pi by 4 is my phase phi, and this is my period. Did you get it? So whenever I write over here pi, this will be pi plus pi by 4. 2 pi plus pi by 4. Because the entire waveform is, let's say, shifted by pi by 4 as if. Alright? So here the phase angle is minus 45. Did you understand why minus? Because it is going after a delay. So the delay is termed as negative. If it started before 0, then it would have been a positive phase angle. Okay? So draw the waveform and write the phase angle as minus pi by 4. Quickly. I mean, what you do now, first draw the sinusoidal waveform and then draw the axis. Or any way around, we can do it. Quickly do it, please. Just a rough sinusoidal waveform you draw, and it is having a phase angle of minus 45. These are all conceptual things. They won't ask you in the exam, but they will be asked in the numericals. Small things, but it's a part of a bigger numerical. Understood? We are learning AC, so we should learn all its properties. The phase angle, the magnitude, the RMS value, the peak value, the form factor, crest factor, all that we have done last time. So today is the new thing, phase angle. Understood why it is minus 45? Okay. Drawn the waveforms? Completed? So over here, voltage V attains its zero value for the first time after a reference position by pi by 4. So that's why phase angle is pi by 4 radians or 45 degrees, minus actually. So phi is minus 45. So how do we write this waveform? V is equal to Vm sine of omega t minus 45 degree or sine of omega t minus pi by 4. And how do you represent the phase? Below the x-axis, okay, that will be minus 45 degrees. So draw the phasor diagram. This is the phasor diagram. All right. Write this formula also. I mean, not the expression. What is the expression says? V is equal to Vm sine omega t minus 45 or minus pi by 4 radians. So this is important. Okay. Completed. Third one, with a positive phase angle, it was said before, whenever a waveform starts earlier than 0, it will have a positive phase angle. Now let's calculate this pi by 6. Pi by 6 into, if you convert into degrees, it will be 30 degree. So this diagram has a phase angle of 30. Okay, how will you write this? I is equal to Im sine omega t plus pi by 6. Correct? So please draw this waveform. So why this is pi minus pi by 6? Because as if the waveform is shifted ahead. Okay, so that's why minus pi by 6. And here it is minus 2 pi minus pi by 6. So this is my phase phi and this is my period t. Draw the waveforms. So this current waveform has a phase angle of plus 30 degree or plus pi by 6 radians. Okay, that phasor diagram में x axis is theta or omega t, we can say. Completed this? So here current will attain its value for the first time before a reference position. That's why the phase angle is plus 30 degree or pi by 6 radians. So write this formula. I mean expression I is equal to Im sine omega t plus 30 degree and draw this phasor diagram where x axis is theta or omega t. Actually, I should have written it everywhere, but it's fine. So this is a positive phase angle. Completed? You should know just by looking at the waveform how to write the expression, that's it. So this 5-10 minutes was for that. Alright? Can we start with the actual topic? Now what do you mean by in-phase signal? If there are two signals starting with the same reference position, they are in phase. Alright? They are reaching zero at the same point, reaching maximum at the same position, then it's in phase signal. So here V1 and V2 are of same frequency and are in phase. What do you mean by same frequency? Their time period is same, but the amplitude might be different. Okay, so V1 and V2 over here, V1 is blue in color. You can view now. V1 and V2 are in phase and same frequency. Okay, so V1 is represented by Vm1 sin omega t, V2 is represented by Vm2 sin omega t. Okay, and your phase angle between them is 0. Got it? Now I'll show you out of phase signal. Draw this out of phase signal, please. Or you can watch it just, it's okay. So we have a voltage waveform. Let me show it to you here. We have a voltage waveform red in color. So its expression is Vm sin omega t. Any problem in that? No. Current I has a phase angle minus or positive? I mean negative or positive? Negative. And what is the phase angle? 30 degrees. So I will be Im sin omega t minus pi by 6. Alright. Are they out of phase signals? Yes. They are not starting at the same time, right? And they have a different amplitude. Are they frequencies same? Probably yes. Frequencies might be similar. Okay. So this is the phase angle phi. So how do you write it? V is equal to Vm sin omega t and I is Im sin omega t minus 30 degree. So what's the phase difference between them? They are out of phase by what? How much degrees? 30 degrees, pi by 6. That's what we have written over here. So we say current lags behind the voltage by 30 degree. Learn this language. So just by looking at the waveform, current I is lagging behind the voltage by 30 degree. Or we can say voltage is leading the current by 30 degree. Did you understand both the statements? Voltage is leading by 30 or current is lagging by 30 degree. You should understand this. Got it? Understood? Out of phase signal? Okay, fine. Now, write down this topic. Phasor representation in rectangular and polar form. Phasor representation in rectangular or polar form. Okay, so just wait now. So mathematically, we can represent any phase, current or a voltage in our case, and the mathematical represent is called as phasor algebra. Okay, this phasor can be represented mathematically in two forms: rectangular form and polar form. I guess yesterday, before leaving the lecture, I taught you how to use it in the calculator. Still, I repeat it once more today while solving the numerical. So phasor can be represented in two forms: rectangular or polar form. So let's understand it. You need to draw this diagram. I mean the real axis and imaginary axis. So let's say you have a real axis and imaginary axis. You know what is J or I, right? Complex number. You have studied in mathematics, right? So here, just draw this. We have a vector V whose x coordinate is A and y coordinate is B. And it is making a phase angle of theta degree. Okay. So what is the magnitude of V? Square root of A square plus B square. Magnitude of this vector V. So J is same as I don't know. You have studied as I or J in mathematics? I. So I is same. In a calculators also you will see I only. And I square is minus 1. You all know that, right? Okay. So V is a vector represented by A plus JB. So write in this form. This is a rectangular form. Drawn? So this is A, this is A, this is B, this is B. Please draw it fast. So V has a vector having a phase angle of phi, x axis, x coordinate as A and B, y coordinate as B. So what is rectangular form? We'll see this later. It is actually used for addition or subtraction of AC quantities. If you want to add or subtract AC quantities, you use in rectangular form. And the rectangular form of a vector is represented by real part x-axis and imaginary part of the vector. So V is equal to A plus JB. Write it down. Write down rectangular form and write down this vector. V is equal given by A plus JB or IB, whatever you want to call it. Got it? And this vector ka magnitude will be square root of A square plus B square. And what will be the phase? Phase angle given by tan inverse of B by A. So that is called as theta. So I know you know it already. Please write it down still. So this is which form? This is which form we are talking about? Rectangular form. Okay. And why do we use vector rectangular form? For addition or subtraction of vectors of quantities, whether it's a current or a voltage. Completed? Okay. Now we go to polar form. Completed this much? Now we go to polar form. Polar form is used for multiplication and division. If you want to divide any AC quantity or multiply, we use the polar form. So write polar form, and it's represented by its magnitude and angle. Now what was the magnitude of rectangular form? Square root of a square b square. And what was the angle? Tan inverse of v by a. So here is represented like this, where v vector v is capital V angle theta. So this is the polar form. This is the polar form. Where what is V over here? Square root of A square plus B square. You have written it last time. And what is theta? Tan inverse of V by. But you no need to do it in calculator. Calculator directly gives you the result. Okay. So this is the polar form. It's represented by V magnitude angle theta. Got it? Okay. Now actually this we have done it already. Next is rectangular to polar. Those who are not present yesterday, you can write it down. If you want to convert rectangular to polar, you use calculator. So this is, let me expand it more. Now it is more clear. Okay. So rectangular form is A plus JB or A plus IB, and polar form is V is equal to capital V angle theta. So if you want to convert this thing, rectangular to polar, what do you do in the calculator? In the calculator, you press shift rect. Okay, and whatever number is you put separated by comma, that converts rectangular to polar. Okay, so the result will be in polar form. If you want to do it in mathematical way, you want to find out the value of V and theta by this formula. So this is the math way and this is calculator way, and definitely recommend using calculator directly. Got it? Similarly, you have polar to rectangular. So if you want to use from polar to rectangular in the calculator, what you will use? Shift TOL, right? And bracket may will separate it by numbers, whatever positive, negative, whatever it is. If you want to convert into math way, A will be V cos theta, B will be V sin theta. Got it? You can do that way also, but use a calculator instead. Understood everyone? How to convert polar to rectangular and rectangular to polar using calculator and using mathematical way? Okay. So now, yeah, that will be the end of part A lecture. And now we'll actually start solving numericals. Got it? Okay, so let's do that. So please write down numerical number 1. This will be 16B, and today's date is 12/9/23. Okay, write down numerical number 1 in this. Add the currents. So add the currents. I1 is given by 565.69 sine of omega t plus 200 degrees, and unit is amperes. I2 is 10 sine omega t plus 100 degrees. Now do you understand what is that plus 100 plus 200? Phase angle. And what is this 565.69? IM. You got it now. So let's start solving right away. So please be along with me. If you find something difficult, please let me know. I'll expand it even further so that we have clarity over here. What is the standard form? I is equal to Im sine of omega t. In this case, we have plus theta, right? So plus theta. This is the standard form. So first step is convert I1 and I2 into polar form. So first of all, before converting that, okay, now tell me, what is this I1? I1, I'm writing it again. It is 565.69 sine of omega t plus 200, right? Now let me call this as IM1, representing magnitude, peak magnitude of I1, right? And this as phi1, right? So what is I1 RMS value? IM1 divided by root 2, right? So please calculate this number. 565.69 divided by root 2. How much it is? 400 amperes. Yes. This value is IM1, right? We want RMS value. तो RMS कैसे calculate करोगे? Peak divided by root 2. So IM divided by root 2 we will calculate. Next, calculate similarly for I1 also. I2 also. So I2 is 10 sine omega t plus 100 degrees. So let's call this as IM2 and this is 5. So please calculate now I2 RMS is IM2 by root 2, which will be 10 by root 2, which will be 7.07, right? 7.07 amperes. Okay. Now you will wonder how to write in polar form. What is the polar form? Magnitude, angle, right? Comma angle, right? What is the polar form? So we will convert into polar form. Did everyone got this? Now please listen carefully. Now we'll write I1 and I2 in polar form. Let me use a green color. So see what I'm doing. 400, what is the angle? This is polar form directly. RMS value, if you get, that is a polar form. And similarly, what is I2? 7.07 angle. This thing. Got it? Understood? How we wrote this 400? This is the RMS value. The angle 200. Here is the angle 200. And this is again the RMS value, angle 100. So I1 and I2 are in polar form now. But see, read the question. What was the question? What was the question? We need to add, right? Can we add in a polar form? No. We have to convert this into rectangular now. Okay. So step number 1 was convert I1 and I2 into polar form. We have completed in step number 2. Now next is convert this into rectangular form. So how will you convert I1? So in calculator, what you will do? Rect 400 comma 200. Okay. What you will get? Tell me the answer. In a calculator, press shift plus rect. This is in calculator. Minus 375, right? Minus 375.87 minus. So you write it in this form. Okay? As it is. Now tell me I2 minus 1.227, right? Plus J 6.936. So here you will press shift plus rect 7.07 comma 100. Did you get this answer? Yes. Yes. Exactly correct. So this are in rectangular form. Are you getting it? So now in the fourth step, what is totally current now? We need to add it, right? Can we add it now? Yes. So add it, please. Real numbers and complex number, you can add it, right? So add it directly in your calculator. Or you can just add it like this. It will be how much? Minus 377.097 minus J 129.84. Did you get this? Amperes. So this is in rectangular form. Okay? Got it? Completed? Yeah? Completed up till here? Did you understand how we got these numbers? Just add them, that's it. Now, is this the final result? No. This is in rectangular. Which form we want? We want in this form. So now what we need to do? Convert this back to polar and from there convert into standard form. So please convert it into polar now. So how will you do that? So we write convert rectangular to polar. So calculate IT. So what you will do, shift plus POL. It is POL only, na? So you'll write 377.097 comma minus 129.84. So what do you get? Tell me. 398.8 at angle minus 160.99, right? Exactly this. Oh, sorry. Complete. हम minus 161 है ना, देखो वही लिखा है ना. Now this is in polar form, right? So polar form में what will be this? This is IRMS. But हमें क्या चाहिए? We want peak value. So what is peak value? Root 2 times VRMS. So multiply this number by root 2. Are you following? So what do you get? IM 564 amperes. Just check. Are you following, right? This is in RMS form. Now last step will be converting into standard form. What is the standard form? IT is equal to IM sine of omega t plus minus phi. So how will you write this? IM is 564 sine of omega t minus 160.99. That is the answer. This is the standard form. So first we converted standard into polar, polar into rectangular, added in rectangular, then the resultant again into polar and then again into standard form. Got it? So this is IM and this is your phi. Comfortable now in polar and rectangular, rectangular to polar? Okay. Everyone completed up till here? You all require some time? No? Okay, write down numerical number 2. Numerical number 2 says V1 is 60 sine theta. V2 is 40 sine theta plus pi by 3. Find VA equal to V1 plus V2 and VB equal to V1 minus V2. Oh, V1 is 60 sine theta, V2 is 40 sine theta plus pi by 3. Pi by 3 is 60 degree, right? find V1 plus V2 and V1 minus V2. That is VA and VB. You all have understood now? So start. What is the standard form? V is given by Vm sine of omega t, or we can write in terms of theta omega t plus minus phi. Okay, that's the standard form. So how will you start? You first write the standard form. So V1 is 60 sine theta, V2 is 40 sine of theta plus pi by 3. So tell me, what is V1 RMS? This is what? How much is this? This is VM1, right? Peak value. And your phase angle is 0. This is VM2. This is phi 2. Okay. Now tell me, what is V1 RMS? VM1 divided by root 2. That is 60 by root 2. How much? 42.43. V2 RMS is 40 divided by root 2. That is VM2, right? That is 28.28. Please calculate, check with your own calculators. Don't just sit here and write the answers. Now tell me, what do we do next? Polar form, right? So what is V1 now? 42.43 angle 0 volts. And what is V2? 28.28 angle 60 degree. If you have problem in converting, pi by 3 multiplied by 180 by pi, that is 60 degree. Understood? Now what do? We need to add and subtract, right? So we need to convert this polar to rectangular. So third step is polar to rectangular. So tell me V1 value. 42.43 plus J0, right? V2 value will be 14.14 plus J 24.49. I hope how you know by now how to do it in calculator, right? Shift plus rect 42.43 comma 0, and this will be shift plus rect 28.28 comma 60. Did you get this answer? Yes. Please check. Okay. Now can we add them and subtract them? Yes. So now write down 4 VA is V1 plus V2. Now add them together. How much it will be? 56.57 plus J 24.49 volt. Okay. So first we will complete the analysis for VA. So this is now in which form? Rectangular. We need to convert back to polar form. This is in rect. So do polar form now. So VA will be how much? 61.64 angle 23.41 volt. Got it? Now this is the peak value, right? This is VM or okay, VM1, let's say. So what is VA RMS or VA peak value? I mean, this is sorry, this is RMS. VA RMS. So what is VAM? So root 2 times VA RMS. So that will be root 2 times 61.64. So VAM will be how much? 87.17 volt. So now what is the standard form now? Sine omega t plus 23.41. That's it. This is my standard form. Understanding? It's a repetitive steps now. Are you following? First standard to polar, then polar to rectangular, then addition in rectangular, then again to polar, and then to standard. Now VP. Calculate for VP alone on your own. What is VP? V1 minus V2. What is V1 minus V2? This subtract with this. So that will be 28.29 minus J 24.49. So write down 28.29 minus J 24.49. This is in which form? Rectangular, right? Convert into polar and write VP. What is VP? 37.42. Please check at an angle minus 40.88. So how you do it in calculator? Shift plus polar bracket 28.29 comma minus 24.49. Are you getting these numbers? Yes. But this is what? VRMS V value, right? We want VMB, peak value. So what it will be? Root 2 times VRMS V. So root 2 times this value. How much is this? 52.92. So now write it in standard form. 52.92 sine of omega t minus 40.88 degrees. So this is the standard form of V. He was closer to. Are you following? Or am I too fast? Actually, it's the conversion which you need to do in your calculators. You need to practice polar to rectangular, rectangular to polar, and you should know how to extract the information. You should be thorough in that. Okay? So please complete it. Understood? Yeah? Can we move on now to next numericals? So write down. This was numerical number 3, now. Okay, still some students. 2. So this is 3 now. Next. Okay. Is the font okay enough for you all? Everyone can view from behind? Okay. Next, we write down numerical number 3. And voltage is defined as minus Vm cos omega t. Express it in polar form. A voltage is defined as minus Vm cos omega t. Express it in polar form. Don't forget the standard value. What is the standard form for voltage? Vm sin omega t. How will you convert into cos? What is cos pi? Cos alpha sin alpha plus pi by 2. Yes or no? Mathematics. And what is minus sin alpha? Sin alpha plus pi. So remember these two mathematical quantities. You can open the bracket now, it will get the same thing. Okay. So how do you express this now? V is equal to Acha, it is minus given, na? Acha, minus Vm cos omega t. How will you write this? Minus Vm. What is cos omega t? Here you can write it as sin omega t plus pi by 2. Got it? And if you want to remove the sign, what is minus sin alpha? अगर मुझे ये sign निकालना है, तो what will I do? Add another plus pi. Okay, so it will be Vm. Sorry, are you understanding? Now minus sin alpha will be sin alpha plus pi. So I'll add plus pi again. So it will be Vm sin omega t plus pi by 2. Did you understand? नहीं. See, minus cos, how does sin plus pi by 2 came, understood? Now sin भी minus है. Now if you want to remove the minus sign, you have to add pi again from this formula. Got it? That's why pi plus pi by 2. So 180 plus 90. Did you understand behind? We have removed negative sign, so you have to add pi. So now tell me what will be the standard form? Okay, V is equal to Vm sin omega t plus 270 degree, 3 pi by 2 or 270 degree. Is this the polar form? So intelligently batao, what will be the polar form? If you can answer this, then you have understood everything. It will be Vm by root 2 angle. Got it? This is the polar form. So write it down, please. Note it down. See, one thing remember, if you give me more time, I can solve more numericals. And the more numericals I solve, the more numericals you can practice. This is the polar form. Understood? Now, and we will not solve two numericals same. We'll solve different variety of numericals. Okay? Anyone has any doubt? It's a simple thing, but it has a meaning to it. Now write down numerical number 4, right? Yeah. Two currents. I1 is 10 angle 50 degrees amperes. I2 is 5 angle minus 100 amperes. Flow in a single phase AC circuit. Flow in a single phase AC circuit. Calculate first I1 plus I2, I1 into I2. These are vector form. And third, I1 divided by I2. Meaning that we need to add, we need to multiply, and we need to divide. Multiply and divide in which form? Polar form. In polar form, we have to convert it. And for adding, rectangular form. Correct. Acha. First we'll do second and third. Okay. So let's solve it together. Please use your calculators. If you're not using your calculators, you're not doing anything in the lecture. Okay. We'll solve the second case first. I1 multiplied by I2. So how will you do that? 10 angle 40 degree multiplied by pi angle minus 100. Acha, how do you multiply them? I'll give you a clue. So you multiply magnitude 10 into 5, 250 हो गया, ठीक है? What will you do with the angle? Angle you will add. समझ में आया? That is the meaning of multiplication. Okay. So now what you will get? Are you understanding what I'm doing over here? This magnitude you will multiply and angles you will add. So now I1 into I2 will be how much? 50 angle minus 50, and that is the answer. Easy. So let it remain in the polar form only, and we have multiplied them together. What about division? I1 divided by I2 will be what? 10 angle 50 degree divided by 5 angle 100. So how will you, divide them? See, if it is magnitude, you can divide it like this, 5. But what about the angles? Angles will subtract. So 50 minus or minus 100, so that will be 150. Got it? So what will be the answer? I1 divided by I2 will be, sorry, this will be 2, na? So 2 angle 150 degree. And that is the answer. Got it? One remains I1 plus I2. So how will you do that? First convert into rectangular and add them. Okay? So please do that, please. So you need to calculate now next. First one. I1 plus I. You need to find that. So first of all, write I1 and I2. I1 is how much? 10 angle 50. Convert into rectangular. 6.4278 plus J 7.66. Is this the one? And what is I2? 5 angle minus 100. So this will be minus 0.868 minus J 4.924. Please check. This is in rectangular form, correct? And now we add them. So I1 plus I2. So just add them together. What you will get? 5.5598 plus J 2.73. Okay. And if you want to convert into the polar form, you can convert it. If you wish to convert it, 6.196 angle 26.2 amperes. Got it? So this again is my answer. Okay, we will solve now. The next numerical will be the last for today, and that will wind up. Okay, so rectangular to polar topic will be completed, and phasor also will be completed. Are you following? Next time we'll start with RC, RL circuits, series circuits, and then parallel. Fine? Got similar answers? So write down numerical number 5. Two voltages having RMS value of 50 volt and 75 volt. Two voltages having RMS value of 50 volt and 75 volt have a phase difference of 60 degree. Find the resultant sum of these two voltages. Find the resultant sum of these two voltages. Now, come on. I'll give you 2 minutes. Try to solve this on your own. I'll not give you any clue. Please try to solve this on your own. Two voltages having RMS value of 50 and 75 have a phase difference of 60 degree. Find the resultant sum of these two voltages. Okay, a little clue. I'll give you a little clue. V1 is RMS, right? This is RMS value, right? How much it is? 50. V2 RMS is how much? 75. And what is given? The phase difference between them is given as 60. So how will you write V1 in polar form? V1 bar in polar form, how will you write? 50 angle 0. And V2, how will you write? 75 angle minus 60. Did you understand? Phase difference between them is 60. So one will be 0, other will be minus 60. हाँ डिफरेंस है ना दोनों में लीडिंग लैगिंग नहीं बोला है ना सो बाय डिफॉल्ट इट्स माइनस अगर लीडिंग बोला होता तो देन वीड हैव रिटन प्लस okay now you know what to do convert this polar into rectangular and add them that's it so converting now v1 write it in this thing rectangular form it will be 50 plus j0 v2 will be 37.5 minus j 64.95 are you getting these answers and now please add them together so v1 plus v2 will be 87.5 minus j 64.95 volt. Convert them into polar again. You will get 108.97 at an angle minus 36.58 volts. So that's the answer. This is in polar form. Okay? Got the same answer? And requesting everyone, those who are not still carrying the calculators, everyone has a calculator over here. Calculator. Buy it, please. Don't forget calculators in engineering lectures. Keep it inside your bags only, na? Don't remove it only. So you'll not forget to carry. Next time, I'll just give you a preview. Just like in episodes, they give you a preview of the next episode. So, preview of the next lecture will be, I'll start with AC circuits with R only, L only, and C only. Meaning, we will study the behavior of AC circuits with R alone, resistance alone, capacitance alone, and inductance alone. Alright, so that we will do next time.